So, welcome back. So, for this afternoon, we are going to talk about sustainability aspect and food systems approach. So, in the morning we were dealing about different types of economy, circular economy, blue circular economy. So, till now you would have understood what we mean really by blue circular economy and what are different facets to it and how we can establish that. We are going to cover basically three different things. One is how do we define sustainable food system? And if you remember morning I was saying about sustainability versus resilience, what is the key and how we address the missing gaps, because when we talk about sustainability, what is wrong with the current system and what is missing to make it more sustainable, and give you some examples of the case study and not exactly related to blue economy because we will be dealing with those in coming lectures. So, what are the current actions? So, if in morning I was mentioning about farm to fork approach, that is how it is produced all the way how it is consumed. So, everything is recorded in a document called European Green Deal. That means how do we green whole of the process, and it is striving to be the first climate neutral continent by 2050, because we have to be climate neutral by 2050. And I did indicate India is pledged to be carbon neutral by 2070, and some other countries having different years for carbon neutrality. So, what are the actions there? One is our own national priority is to reduce waste by 50% by the end of 2030. That's a big challenge, and still different actions has been done, different documents have been prepared, and action plans are in place to achieve this. And in the morning we already discussed how much the waste causes the greenhouse gas emissions, and if you account total food losses and food waste globally, so it can be considered as third biggest continent on this earth. So, if you are interested in reading those documents, I'll suggest you to, even if you Google these titles, you'll be able to find those documents or at the web link given below. One is National Food Waste Prevention Roadmap, Food Vision 2030, that is again sustainable food systems, what are the priorities and how they should be established. Chagas Together, that means how we take the power of research, advisory and education to create a sustainable food systems. That means it is not only the responsibility of scientists or researchers, but also all those who are involved in research activities, training, education and advisory. And Bioeconomy Action Plan, which we already discussed this morning. So, so together with these things, what we really mean by farm to fork, that includes sustainable food production to create bioresources, processing and distribution, that is sustainable. So, every word is having one additional word called sustainable, yeah, whether it's a production, processing, distribution, consumption, or reducing the waste or using the waste in some form or the other to bring it back into the system to make it circle. So, in order to understand this, first we need to know what do we really mean by food system. So, if you take any crop or any product, this starts with what? Biomass, that is natural resource that is grown agronomically, that is goes into production. We have harvest and post-harvest handling processes, food processing, distribution and retail, and product consumption. That's fairly linear system. There is no issues with that. Wheat is grown in a field, you harvest it, you process it, you make into flour, and that flour is converted into bread, bakery products, or range of different products. You distribute it, and then you consume it. So that's the simple system. So, how do we define a food system? It represents a contrast or notion on agriculture, food production and consumption as a simple linear chain from farm to table. Yeah. So, that's a simple system. And what we study is different unit operations. When we combine unit operations together, we make a process. And then all these different processes together make a complete system. So, if this system becomes quite complicated, the moment we divide this big food system into simpler systems. One is biological system, which deals with bioresources, for example, crops, seeds and everything. Economic system, all the finances and benefits, yield, production, cost involved, that comes into economic system. What will be in a political system?
Sir, I think GDP in the sense.
Yeah, political system is again trade barriers. You can sell into different geographical location what you can grow, conditions of it, and all those regulations, legislations, they all come into political systems. And again, what crop is grown based on where the subsidy is given or fair trade prices, and all those things comes into political system. Social system, again, livelihood, employment, nutritional aspect, all this thing comes into social system. And health, that's again health and wellness, what are the benefits you're getting out of it. So now you can see, we scientists are known to complicate things. Yeah, it's so simple, production to consumption, but if we divide this into multiple systems, we get all these systems. So now if we have to introduce sustainability, we have to look into this system. It becomes slightly more complicated when you expand it. So if you take it only the biological system, that is biodiversity, land use, climate change, pollution, animal welfare. Animal welfare comes in if you're dealing with animal production system or meat production system. Then you have economic system, that is wholesaler, companies. Then you have farmers, market, grocery stores and restaurants, that's all economic system. Then you have your political system, regulation, tax, subsidies, ownership, trade, all these things comes into political system. You have social system, that is social networks, media, access, education, food, culture. You grow something, produce in a way which is not absorbed by a community, a certain community, because they want to have food processed in a particular manner. So all this thing comes into social aspect that dictates your demand. And health system, wellness, care, food safety, food security, nutrition and wellness. So as you can see, whole of the farming system, there are environmental credentials, you have economic credentials, and this was a social credentials which dictate social aspect, and you have all these inputs. So as you can see how complicated the system is all there when it comes to food system. So what way we can make system more sustainable? It's not easy to just make it a circle, it becomes circular, or to write a sustainable, it becomes sustainable. Drinking tea in a paper cup, we'll see most of the students, most of the researchers say, oh, it's more sustainable than drinking in a plastic cup. Do you think it's that simple? No, it's not that simple. Drinking water in a plastic bottle is more sustainable, or into a glass bottle is more sustainable. So those are the questions that's not easy to answer. Simple answer is yes, it is more sustainable because it looks sustainable. Yeah. So now coming back to the concept of resilience and sustainability, any idea what will differentiate what is resilience and what is sustainable? We'll take the system, right? Suppose we try to see a system is sustainable over time. Suppose something is running. Take any example. Suppose even any coastal area, there was a flood recently in southern part of the country, and suppose system takes a hit. There is a disturbance. Flood happens. Everything is disturbed. What will happen? System takes a hit. Yeah. Then we absorb that change. Suppose COVID was there and then our system was disturbed. Then we adapted that change and we try to recover from that change. That means instead of traveling, we started having online meetings, or online and distance learning started. So we try to recover and to adapt to a new change. And if we are able to absorb, recover and adapt and come to the system which is the same as previously, it is resilient. If it is not same as the previous, it becomes anti-resilient. So most of the sustainability, climate change and all those issues which are coming in, we have a benchmark. We want to bring our carbon emission back to 1990 level or 1930 level, 1950. There's always a benchmark. Yeah. So if we have any of the changes, take any example, for instance, chlorine. Chlorine is used extensively for washing of fruits and vegetables. And even in seafood sector, it is used chlorine. But certain countries, chlorine is completely banned to use it on, is not used in meat sector or in seafood sector. So what you have alternative to chlorine? You'll say plasma, which you would have seen today, or natural antimicrobial and all those agents. So if chlorine is banned by FSSAI tomorrow, then all this industry will suffer. So they have to come up with a new change. Then they recover and they make the same profit economically, environmentally and other aspects same as what they were pre-chlorine. So that becomes resilient or anti-resilient system. Is it clear? Yeah. Now, if this disturbance becomes economic, cost-wise, social or environment over the time, yeah. So these disturbances can be economic disturbance, social disturbances or economic disturbance, or environmental disturbances over the time, that makes it sustainable or unsustainable system. Because food system is not based on paper cup or a plastic cup, but based on multiple subsystems. So if you define resilience, capacity over time in face of disturbance, that is absorb, adapt and recover. Whereas capacity to preserve in a long run, for those changes, environment, social and economic become sustainable. Yeah. So now I leave the choice on to you whether to use term resilience or to use sustainable. Yeah. So these are also at the same time systems are ongoing to define the sustainability. Yeah. That becomes important terminology for agri-food system. Do you have any questions so far? Because this is very important to be having clear idea what is sustainable, what is non-sustainable. So, how do we define sustainable system or unsustainable? First point, unsustainable system will focus on high resource consumption. Example, fossil-based fuels. Sustainable, we'll talk about renewable biomass. That means which biomass can be renewed, can be produced or is produced constantly without much impact on other aspects. Second point, agriculture dependent on chemical input, alternative green chemical, fertilizer, chemical fertilizer versus biofertilizer. Third point, greenhouse gas emissions. The huge amount of greenhouse gas emissions happens in unsustainable system, whereas target net zero emission, that means no emissions coming out of it. Food waste, huge amount of food waste and we don't worry about the waste. It's generated, it's just dumped. Whereas we endeavor to achieve zero waste, that means nothing is wasted, everything is used. Can you think of any food system where we can create zero waste, that means nothing is wasted, everything can be utilized? There can be a number of examples. Or how you can establish zero waste. Think of any production line, come up with the approach how to make a zero waste and you have a perfect writer. So it requires a lot of thinking process. And then you read a scientific literature how to extract and obtain stuff and then use that knowledge to create your own system. Yeah. So then it makes proper sense. Rather than reading it how to extract a pectin, and focus is only on extraction of pectin from apple, but you can also get it from orange peel. You can also get it from lot of plants. Why only apple or only lemon? Just because somebody else has done it. Do you understand that when we go in a railway station, we'll see there's a door, everybody rushes to the same door, but there's another door. That's why if you fly in an aircraft, it says nearest emergency door might be behind you, but we keep seeing only in the front. Yeah. So that's important. Other one is centralized supply chain. That means everything goes to one place and then it's distributed. So you have a lot of carbon footprint. Whereas you focus on local and short supply chain. That means making a shorter loop. So that means you are having less amount of emissions through transportation or so. Local bakery versus national bakeries, which supplies bread from Delhi to different part of the city, or the bread is processed in a city and consumed locally. Yeah. Then Other one is social inequality and social equality. Here again you have a gender balance, gender dimension, you have you have nutrition, food for all, food security, food safety, and everything is included into social. So I only listed on the few points. I could have gone on economic, another one to make you, to take a revenge, to make you more bored. So I just focusing only on those points which are relevant somewhat with our subsequent modules. Yeah. Do you have any question related to how we can define sustainable or unsustainable systems? You may have plenty of ideas coming in. You might have 100 different points. You may agree with certain points. You may not agree with certain points. Or it's a mix of both. Yeah. So, the question is whether can we make completely sustainable process or not? A. B. Can we really achieve zero waste processes? Theoretically, yes. Practically, yes or no. That's the question what you should be able to answer, and when we go towards the end. And in between, if you have any ideas coming in, don't think that, oh, if I'll say this, it might be looking, the idea might look stupid. Nothing is stupid. Everything is workable. Yeah. Feel free to say. Yeah. Now, if you'll see the whole story of the food system is, if you'll see this particular wheel, this is your natural element. Oh, one. Then you have societal element. Then you have a core system, right? Natural element is related to air, soil, ecosystem, water, climate, and all other naturally present. Yeah. Air is renewable, isn't it? Water is renewable. Ecosystem, genetics, and climate, soil, and air. So all these are natural elements. Societal, that is organization, policy, law, regulation, infrastructure, socio-cultural norms. And then you have a core system related to production, aggregation, processing, distribution, consumption. So these can be changed. These are just a generalized version of system. And then you have your access to natural resources. If water is there, do you have access to it? Labor, input, knowledge, finance, and other services. So whole bit is to make a proper balance between economy, environment, and ecosystem. If you are able to balance 3 E's, we will be having a step towards sustainable food system. So how can we achieve a robust balance between these 3 E's? Any suggestion? One, how do we have an alternative on-farm activities that is related to production? Yeah. That means even you are producing marine resources or a crop or anything, how do we make alternative on-farm production system? Second stuff is disruptive technologies. So what do you think, what I mean here by disruptive technologies? This is not a technology to disrupt the cell matrix. No. Yeah. What will be a disruptive technology? How to disturb it or to disrupt the system. Suppose a process line is milk is obtained, you use thermal processing, you pack it into a plastic container and you distribute. This is the normal process, involves different technology. If you want to disrupt this by removing the plastic to bring in biodegradable polymer, or instead of using thermal processing, you employ high pressure, pulse electric field or new technology. So you are disturbing the status quo. Every day you are doing the same activity is the normal system. When you disrupt it by using any intervention, any technology, it becomes disruptive technology. Yeah, along agri-food system. Third one is to achieve zero waste approach. How we can achieve zero waste, that is nothing is wasted. Zero waste here means even not wasting the energy or water used within the system. Yeah. So how we can do it? One, any idea how we can do it? Or what should be the focus? So if you'll see this particular diagram, this is all to do with EU bioeconomy. Sorry, I'm keep quoting EU example because this is what I know I am aware of. And the similar systems are there everywhere. US system is there, Australian, even in India system is there. If you'll see this particular diagram very, very carefully, first line on here is using better what we already use. Yeah? That means whatever we are using, how best we can make use of it. That means whatever product we consume, how we can have a better usage of it. So second one is unlocking or using well what we don't use yet. That means unlocking the potential of seas and ocean. We are in India, we are very well blessed with having a long coastline. Lot of resources are there, lot of facilities, a lot of biological resources are there which are not tapped at the moment. Yeah. So that is one thing how we can unlock the potential of seas and ocean. And by doing so, we are able to we can achieve long-term sustainability developmental goal, climate change, because oceans are the biggest sink for CO2. Whatever is emitted, trees and plants are there, but ocean is the biggest CO2 sink. Natural resource management, job growth, competitiveness and inclusivity, global sustainability, responsible development within sustainable and sustainable consumption. So by using these two approaches, we will be able to achieve sustainable bioeconomy, that is moving from fossil based towards a bioeconomy, we already discussed, and ensuring food security. So this diagram encompasses everything related to bioeconomy and what should be our focus. So key point, one is climate, that is cut emissions, reduce carbon footprint. We already discussed local supply chain. Agriculture, restore nature on farms is not only energy intensive agriculture or pesticide or chemical fertilizer based agriculture. Sustainable diet, affordable, healthy and sustainable diets. Food waste, first we have to target, measure how much it is produced and then act on it, because we don't know how much food is wasted. Because there is always, when we see it, then we think about it. But there are a lot of other things which are wasted in a region, whereas in other region it is not. Suppose consuming whole potatoes without peeling. Lot of restaurants you'll see, whole potatoes are consumed without peeling. So, and some places abrasive peeling is done, some places take example of French fries. When we peel it, we almost lose 2 to 3% of solid in a form of starch. Whereas other industry who produces starch from potato, which is used in product making. And starch production industry throws lot of protein of potato into the wastewater, which is again your potato protein. Yeah. So how we can link two systems, that is translating approaches from one place to another. Fisheries and aquaculture, that is protecting seas and ponds and ocean. Packaging, remove, reduce or reuse or recycle. We all know about packaging. Everybody is aware of it. Everywhere, like the moment they put 10 rupee cent on a plastic bag, plastic consumption reduced drastically. Same way in Germany, the moment 10 cent was charged for the cup, if you use your own cup, amount of cup waste was reduced drastically. Yeah. So either by incentive, that's again policy decision, or by individual itself. If you carry with your own cup, you get less, you don't have to pay more money there. Costa, Starbucks and all, they introduce their cups to reuse it. Again, deforestation and conversion, that is preserving natural habitat. These are some of the points broadly related to what should be our focus. So coming back to step 1, altering our on-farm processes. So this is again, as I said about EU Green Deal or EU Farm to Fork. And I must say, whether the problem of the climate is for Europe, America, same climate problems are also there in Asia as well. So what should be the target and what is the target? 1, reduce the use of chemical and hazardous pesticide. It is not that just ban all the chemical fertilizer. It will have serious implication. It will help the environment, but people may die of hunger because there is no food available. So we have to take a small but robust step for long-term change. Nutrient losses, reduce nutrient losses by 50% while retaining soil fertility, resulting in 20% fertilizer. I think you would have seen a lot of government initiatives were there to get the soil health card and to see how much fertilizer is required. It is not that every soil requires large amount of fertilizer. Certain crops, they do not need any fertilizer. So you have crop rotation, number of different protocols are there, and lot of what it used to be KVKs, Krishi Vigyan Kendra, and all those are, they do a very good job on advising farmers how to grow and use different techniques. Antimicrobials, reduce sale of antimicrobials from farmed animals and aquaculture. Even for human antibiotics, you cannot buy it in Europe unless until you have prescription. Here you got a cough, you just go and buy an amoxicillin, then throw it. That all is causing antimicrobial resistance because this going in the water, bacteria are, like same thing happened with the COVID. One virus came in, within 2 months a new version came in, the new version came in, they have rapid response to adapt. So in that way, how we can get antimicrobial agents, we can replace natural or which can be a natural antimicrobial. Well, most of antibiotics are natural, but again, we have to have the way how we reduce the usage of antibiotics. Organic farming, that means how we can promote more of organic farming. So you would have seen all these points from the national media. Apart from the political news, you might be seeing all those agendas, what is required to remove the pesticides, nutrient leaches, antimicrobial, organic farming. The problems are the same globally. So how this can be there by altering on-farm activities. Yeah, that is all related to pre-harvest, harvesting. Till that point, this is step A. Second one is disruptive technologies. So if you'll see United Nations Sustainability Developmental 17 goals, the critical part related to disruptive technology of processing is directly related good health and well-being and responsible consumption and production. So where we can use a technology, as you will see, this is a raw material, step number 1. You can place any product over here, whether it's fish, dairy, meat. So what's the most important one? You analyze the raw material quality. Yeah, one is a disruptive technology, that is destructive technology. That means you test each and everything. If you know when you would have studied, you would have got an example of bulbs. A company produces 5,000 bulbs every day and they have to check the strength of the bulb. So what they will do? They'll try to break it. Yeah. But you have to take the sample out of it. But that's a destructive. You are wasting at least 5-6 different bulbs every cycle. So how we can have a new technology which is not destructive? That is, again, you have your hyperspectral imaging tool, NIR spectroscopy, infrared, thermal imaging. Yeah, all those technologies to check the raw material quality. Second one comes novel disinfection. So any product, example, take for example apple. If apple is there, you do the visual inspection or you do with certain types of imaging tools. Yeah, whether it's a camera or color sorter or different techniques are there. Then you have to disinfect the product, whether you use it for juice purpose, to make a jam or jellies or any other product. Then you just now saw cold plasma, ozone, natural antimicrobial as an alternative to chemical. So there are different advantages are there. You have seen plenty of literature is full of all these technologies. Third one is processing technology. Same apple, if it is converted into apple juice, how you are going to process that apple juice instead of thermal processing to create better product, whether it's pulse electric field, high pressure, ultrasonics, or you name it, you can use over here for liquid food. Or if this product is used in a frozen condition, so you have different type of freezing system, whether it includes cold chain or CAS. Have you heard of this cell alive system? Yeah. Cells alive system is a freezing technique where a water molecule is frozen then and there. That means when freezing happens, you would have seen if you keep an ice cream, you take out of the freezer, let it melt and put it back. What happens? Texture is gone. Why it happens? Because water is having a good tendency to coalesce together and makes a needle-shaped structure, and it ruptures the cell and it causes turgidity and texture. The cell-alive system doesn't allow it to happen. Then you also have a pre-treatment of high pressure pulse electric field to control the crystal size so that you have a better texture. Or else to remove those carbon fluorocarbon refrigerant, or to use a new technology for freezing. Then in all this process, you have one of the element that is waste. Waste is generated. If apple is used for apple apple is used for apple juice, what is the waste you are going to generate? Pomace. Yeah. And then how we can valorize that in different places. Then you have a packaging technique. Whatever product is made, whether it's a juice or a product, how we are going to use either active packaging system, smart packaging, or to use biodegradable packaging material. Yeah. And the last one is end product quality assessment. So the same technique, whichever is used for raw material quality assessment, some of those can be retrofitted to make end product quality assessment. Yeah. Does this make sense? So you can put in any product and you can alter the unit operations. Each and every 1 to 7 different steps are related to unit operations. Together we make a process. So focus is to improve food quality, valorization of side streams, byproduct or a waste, reduce energy and water requirement along the chain, to produce clean and green solutions, new interventions for developing new product which can help your nutrition, health and wellness challenges. Yeah. We got 2 different steps. One is altering on-farm activities, all to do with the production, processing technologies to develop different types of product, and third one is waste scenario. That is, how do we establish zero waste? How many of you seen this one before? 3, at least 4. Good. 4 people have seen in after daytime. Yeah. So this is what we have already seen in afternoon. Yeah. So some of the figures and some of the slide you'll see in coming lectures will be coming back again and again. That is one of the way of making a thing circular. Yeah. And this also you have seen. Yeah. Well, you saw it because there was India after this. Yeah. So this is drawn in terms of greenhouse gas emissions as the 3rd biggest continent in terms of food waste and food losses. Yeah. This was there. This was placed over here. This was this side. Now it's gone that side, right? Why it is so? Because first one, all the food waste, what is its implication? Yeah. I have to put these figures back again just to prove the point. It is responsible for 21% of fresh water, 19% of fertilizer. How? Fresh water is understandable, yeah, because you use a water, potable water, to process a product that goes as a waste. That's one. And second one is again polluting the natural water bodies. All those things are calculated. Fertilizer, how come? Very simple. That much amount of fertilizer was used to produce that food product. Yeah. Suppose 1 ton of 100 kg of food needs 1 kg of fertilizer. Out of that, if 20% is lost, so that means 200 gram of fertilizer is also gone as a waste. Yeah. Make sense? Whereas the same waste goes as a biofertilizer. Your colleague in the morning, she is not here, she was saying we can use it for fertilizer, so we can compensate with that, correct? So, third, arable land. Same calculation. Amount of food which was produced goes as a waste, amount of land required to produce A, B is landfill. That means land is required for storing all this waste. And if you have to ever see what's the best country of using the waste, not only the food waste but also city waste, how best it is managed, the perfect example is Singapore. They use it, it's a very small island country, best economically, and how they manage within their limited land. Yeah. Now, landfill volume. What is called the place, Gazipur, having a big piles of food waste and burning the food waste, not food waste, all those city waste and everything. Yeah. So that's called landfill volume. So this is the waste scenario. So how we can make zero waste approach? Now you know what is important, right? So far we dealt with 3 stages. One is altering. My writing is just like a medical doctor's writing, you know. Yeah, it doesn't mean it's difficult to write with this pen, and even though my writing is not that great. So altering on-farm activities, A. B is disruptive technology, yeah. C is zero waste approach, yeah. So these are the 3 different things. Now I'll go with some of the case study, and blue bioeconomy is one such case study. And whatever you will see now next few days, including today, all these are really happening. If you really want to see what is happening in those one, feel free to contact me, and even if you want to see it, you will find all the website where the activities are carried forward. You put it, the same word on the net, you will find exactly the same, yeah. Now, first case study is dairy processing. How many of you are aware of dairy processing system? So some of the people, they are lactose intolerant then. So single source of dairy milk is cow. You get fluid milk, yeah. We process it, cream, cheese, butter, milk powder, infant milk formula, what else? Number of different product comes in, yeah. What are the side streams produced out of dairy processing? Whey protein isolates and, yeah, go on.
Whey protein, mainly whey protein they are producing. So apart from that, spoiled milk also even is a part of, like some of the even lack of proper cold storage system, some batches may be spoiled. And wastewater from the dairy industry, that also contain high amount of protein. And
so milk, if it is spoiled, what is done with that?
I have seen recently some studies are like cotton, like textile industry they are using.
Yeah, paneer and all. Even like suppose milk is spoiled. Milk is mainly spoiled. You know about the process called thermization. Yeah. Have you heard a process called thermization? Because if you see the dairy cooperatives, A farmer gets the milk at 6 o'clock in the morning, B farm gets the milk at 7 o'clock, C farm gets at 9 o'clock. It goes all to the cooperative to process the milk. They can't be running the process for 6 o'clock, 8 o'clock, 9 o'clock or 10 o'clock one. So first and foremost what they do is they do heat it to a certain temperature to inactivate enzymes. Yeah? Am I correct in saying that? What are those enzymes? Alkaline phosphatase, yeah? So that means it alters the pH, causes the milk to spoil, yeah? Even though it is not spoiled pathogenically, yeah? Or microorganisms are not there. To store it for certain time, then they go for processing, yeah? So in nutshell, this is it, what you're saying is correct for the smaller farms and other one, right? So historically, as you know, cows are sacred and they are in one way as a complete sustainable farm. There was a German traveler who wrote how a cow can sustain a family whereas money cannot. Cow produces, suppose a local cow produces 2 liters of milk, 1 liter you keep it for your own family, 1 liter you sell it to buy the other stuff required. Whatever you get as a cow dung is used not only for fuel but also for making an antibacterial and whatever at house, whatever we go in the villages. So that makes a complete sustainable model. That's why there are a lot of stories are there. Somebody wants to have a kg of a gold or a cow. Yeah, people will go for a cow, not for the gold. Yeah. So that's one. Anyway, take an example from this particular process. Whey protein and isolate is a big business, right? Then now after having this, started looking for alpha and beta lactoglobulins, hydrosylates, polylactic acid, sugars and other derivatives, that is lactose. And you heard about PLA films, packaging film, coming from where? Lactic acid, right? So there is no waste generated from the dairy industry as far as Ireland is concerned, right? And you make array of different types of product for consume. But what is the specific side stream which is not looked after? Wastewater. What do you do with that? Nothing. Goes to wastewater treatment plant. You agree? I'm talking of the water not only used for cleaning of the animals, another one, yard, machine, CIP, COP, cleaning in place, cleaning out of place, all those activities requires huge amount of water. What we do with that? That's still a waste. So it is not zero waste, correct? Yeah? You want to say something? Okay. Second one is seafood. Now this is, blue one is quite complicated. Dairy is quite straightforward. You know, it's only one liquid product, we process it. Now, if it comes to seafood, whether it's wild harvest or aquaculture, this example is given only for seafood, not for the plants, another one. You have fish fillet, fish cake, sausages, sauce, ready to eat, ready to serve, ready to consume. A lot of different products are there. Yeah. I'm not going to go into each and every product, so you'll have a lot of products coming out of it. So whatever side streams are there, what all we can obtain? Fish protein. Yeah, it's very simple process for extracting fish protein. Lipids and oils from the side streams. Proteins, chitin, chitosan and other pharmaceutical products. Yeah, and all these things will go through in coming lectures. So I'm not going to go into details of each and every one at this stage. And this is only by using fractionation, conversion and different separation technique. So here again, we can valorize number side stream different ingredient, but still the biggest challenge comes with the same wastewater. Yeah. So what happened to this particular wastewater? Wherever you go, any other factory, they have one thing called wastewater treatment system. Yeah. All the wastewater is collected, it goes into a tank, and what is done in this case?
Reduce the BOD and increase the microbial activity to degrade the organic wastes.
Correct.
Then many separation techniques are done in the process, like initially remove the big particles, then it goes to sieving and filtration techniques are there, and finally aeration is carried out. After that, decanting was done.
Correct. So this is full wastewater treatment system, right? So BOD, COD, aeration, that means you're putting in air, you're putting in energy, then you are using a flocculating agent, yeah, alum, to get the sludge. And that sludge is reduced amount, and that sludge goes as a landfill, right? Yeah. That is the common process. And then water is of some standard which can go back to the natural water. Yeah. How we have a process or how we deal with that water, because now EPA stands for Environmental Protection Agency. Regulation is the water which goes back to the natural water bodies should be same as drinking water. What we'll do with that? You understand what I'm saying? So any wastewater which is dumped back to the natural water is not like all the rivers are getting polluted, everything is dumped into the water. Even wastewater treatment systems are not in place. Now problem has gone much more advanced. The water quality of the natural river should be the same as the drinking water is going into the rivers and water. Yeah. So this can reduce the BOD and COD and a sludge, and sludge itself is a big problem. What we do with the sludge? Yeah. What are the options?
It is used for biogas production due to the sludge processing technique.
True.
Like dumping the sludges and the methane gas is produced from that
And
process.
methane can be used as energy. That's good. You made my work a bit easier. It was coming in, yeah. So that's one. If energy is produced by using methanogenic bacteria to produce an energy, yeah. Now, what energy is produced, there is still a biomass is left, yeah. That's biofertilizer. Now, what we use in the sludge is all the aluminium and all those type of flocculating agent. So what will happen, that aluminium which is left over after energy and everything goes back to the soil. Soil system is imbalanced, correct? So those things are there, right? But there is some solution. But if we question each and every solution, we'll never arrive to some solution, right? So that is again the problem with the wastewater. So biggest challenge itself, one is sludge whatever is produced, but how do we make a water coming out of that sludge of a quality which can be dumped into the river, yeah? Or how we reduce the water usage into the food industry. These are two areas which are critical for using a technology, yeah? Now, other role is when we are reducing a BOD and a COD, so that all the water coming from dairy industry or a meat industry or for brewery or from seafood sector, what nutrient it contains largely? Nitrogen, phosphorus and all those minerals in a form of soluble protein or so. If that water is used to cultivate the same duckweed or same cyanobacteria or other microalgae in a controlled fashion, we create a new biomass, yeah? That means converting inorganic nitrogen phosphorus into organic form, yeah? And then how we use it as for different products, yeah? This is one way of bioremediation, you can call it, or to use it as modifying the water quality and then producing another biomass, yeah? So that is one the biological way, and this is what you will see. If you will see the sequence of the lecture down the road, you will see how we are producing and how this can be done, and this is done at a scale at the moment, yeah? And millions of euros has been invested in establishing these biorefineries on site and on practice, because why industry is putting in money? Because they cannot dump the water what they used to, yeah? Because water quality has to be same as a drinking water. Then what you'll do, yeah? Or pay heavy taxes. So this is what you said about urban waste. This is ongoing project at the moment that is to do with circular biocity waste. That means whatever the wastewater sludge or municipal solid waste coming in, anaerobic digestion, you're one to get an energy, yeah? You get solid and liquid digester, yeah? And then different treatment, agrochemical extraction, that is humic and fulvic acid, yeah? These two are biostimulant, very expensive ingredient when it comes to different types of plants and whatever you call it, aquaponics, hydroponics and different systems. Liquid fertilizer, the solid one goes a bioash, char or hydrochar, yeah? Or to use this one to make an activator. Most of the carbon is gone here, but whatever is left to get a biofertilizer, is still the challenge remains the same as I mentioned about aluminium, and this was accounted when the plant trials were carried out on the soil, yeah? So far it was so rosy picture, that's nice. You can get number of different chemicals, but aluminium toxicity or higher amount of aluminium coming into it, yeah? So this was there. One of the undergrad means graduate students said, oh, that's good, we can extract the aluminium. So aluminium is important metal. Well, nothing wrong in that one, you know. That's one thing. So that's one thing how the plant trials are carried out. And then you have your hydrothermal liquefaction, pyrolysis of these chemicals, and to get energy related to this. Yeah. So this is done at a larger scale and based on EPA one, Environmental Protection Agencies, industries funding, and this is Department of Agriculture, Food and the Marine. That is basically is Ministry of Agriculture or Food. We call it as a department. So this is what is circular city bio waste. Yeah. And here you can characterize any of those solid waste and to follow the sequence of it. Yeah. Do you agree with this? Yeah. And this one, fulvic acid and humic acid extraction is highly alkaline solution. For 24 hours you heat it to get maximum amount of humic acid and fulvic acid. So we were involved in making a process which takes 7.5 minutes to get maximum amount of humic acid and fulvic acid, that by using a cavitation technology. So everything is streamlined in a sequential manner. Yeah. That is used as a disruptive technology. Yeah. So it's not only the cleanness and neatness of the diagram what you see here, but there is already a couple of PhDs and researchers are working on this to doing all the plant trials. And then soil trial, soil was estimated, the mineral profile of the soil and microbiome, everything was okay, but aluminum level was going up. Yeah. So before it is taken into the practice, those points has to be addressed. Yeah. Any question? If you have any good suggestion, let me know, we can implement it then. Yeah. So everything goes in a live format. Live format in the sense any of the project goes in, any of the suggestion comes in, doesn't matter how basic it is, but those are incorporated into it. Because Rome was not built in a day. Yeah. It takes lot of different concepts to get to this one. One person can only do anaerobic digestion, best possible bacteria, best possible microorganisms, best way to trap that energy, and then to see how we can reroute the CO2 or how we use different pre-treatment. Yeah. So, and then this again life cycle assessment to see what is the impact of different processes. Now, how many of you are involved in protein extraction? Somebody said in the morning novel food protein as a microbial source of protein, right? So when you extract a protein from plant or from any crop, so how many of you know how to extract a protein from pulses or from canola meal or from any source?
So from plant protein, there are different methods are there. For example,
Simple one, simple.
Isolate precipitation.
Isoelectric, that means you have a solid material, you add a water with a different ratio, 1:20, you take any extraction, forget about the protein alone. 1:20 ratio, 1:10 ratio, add it, you stir it, yeah, you get an extract, then you dry that extract, yeah, or you precipitate that extract, the water is there, that goes as a waste, yeah. So, a nutshell, if to extract, to obtain 1 kg of plant protein, we need at least 200 kg of water. I am talking about the processing water, not talking about the cleaning water and all is a different story. Because if soybean or take it as any other crop contains 25% protein, so 1 kg of that biomass will produce 250 grams of protein. Yeah, is the best case scenario if everything is extracted. So if we take in 200 liters of water, that will have all the soluble sugars, soluble solids. Yeah. Again, it can go through the wastewater treatment and all those stuff, whatever we discussed in the previous one. So how that can be used is by using alternative microorganisms and then to go for microbial fermentation. That means microorganisms which can consume that sugar to produce the biomass. In the case of dairy wastewater is lactose. If you use lactobacillus cell to consume on that particular sugar, lactobacillus itself will form a source of a protein. Yeah, it will generate a biomass. Yeah, that's microbial source of protein. Yeast hydrosylates you would have studied. All the sugars which are non-fermentable or fermentable sugars, any of the sugar biomass by giving hydrothermal treatment or liquefaction, if you use a microorganism, they will eat that particular microorganism to produce protein on its own. Example is your mushrooms itself, grows on the compost, and that produces different bio ingredient. So this is another way how we make use of biomass to protein, and this is actually again related to national challenge, which was on a 3, like you have startup challenges, similar way how we can make use of a zero waste biorefinery for any given process. The focus mainly is on the liquid waste, which we don't think about. We only focus on the solid waste. But what about the liquid waste, which is one of the most important resource related to water? Because water is disturbed, water ecosystem is disturbed, we have a lot of issues then. Yeah. So this is related to EU circular bioeconomy. If you go on to this particular website, impress-he.eu, what you will see, this is the bigger 6.8 million euros program, yeah, which involves 8 academic partner, that is with us, Chagas being the lead, and then we have couple of, this is a company, Bantry Marine Research Station, which produces seaweeds, that is producing macroalgae. It's back in County Cork. This is an institute which does most of those economic assessment of different processes. To do life cycle economic assessment, New Algae is a company who is producing this microalgae from the wastewater. And then we have your food scale hub to see the businesses, how to create a value chain. Sintef is another company looking after the fish food product. Escol Innovation is an Israeli company who is producing the duckweed, what I showed you from the wastewater. So the whole process, this is what will be from tomorrow onwards. We are going to cover different lectures. Commercially processed fish or seafood, we can generate wastewater or solid byproduct. How we convert these into food ingredients, food products, biopesticide, biofertilizer, biopackaging, and feed ingredient. So that's why the whole of design of this particular program is food and feed value chain, and underutilized species or LTS, low trophic species, how we can convert into different ingredient. Yeah. This is the program which started in 2023 and which will be finishing by 2027. And there are more than 55 researchers across Europe are working on this. Plus Israel, they are working on to achieve this circular bioeconomy in the area of blue bioeconomy. Yeah. So what you will see, and examples given previously was all to do with different crops, dairy and other one. How we take a translational approach from different sectors into marine one, and from seafood you can go into the other sector. That's why in the morning opening address I was saying, you will see some of the things, you will get an idea and then try to implement onto different crops. Yeah. So this acronym was impressive, pretty much same as this one. Now this is another one we just started. As you can see, IMTA, I mentioned. What was IMTA stands for? Morning we talked about IMTA.
Integrated multi-tropic aquaculture system.
Exactly. That's good. At least one was fully awake in the morning. That's great. Thanks. So this is actually in the center of the country. Ireland is not a big country. From here to here, it's around 200 kilometers. It takes 2 hours to reach from this point to this point. Yeah. So this is a peatland, where, as you can see, this is an aerial shot of this place, and all these thing is water, and green one is all the duckweed, and there is a fish growing in it, and that particular duckweed is using the nitrogen which is coming from the fish production to produce a biomass, and that particular biomass will be used for food and feed purposes. Because duckweed as a source of protein has already been approved in multiple countries to use it for human food, and which been used quite extensively in Southeast Asia. We don't use it, but it's the best for animal feed if we are not using it for food purpose. So this is the basically a shot of this, and this is operating at technology readiness level of 8 to 9. That means when we talk about different technology, you got an idea, TRL1, the first stage of development of technology. You prove a concept, 2, 3, 4, 5, 6 to 9. 9 is implementation at real life scenario. So that Mount Lucas site is almost couple of hectares of land, and over here different sensors, that is cloud computing, that is digitalization. The water will be used to grow seaweed, not microalgae, macroalgae, as well as to grow duckweed, what you have seen, the green one, and whatever fish is produced is processed, and the side stream, all these things will be used to develop a biorefinery for both feed and food value chain by using a technology. Yeah. Government has invested 5 million euros, and if you even Google circular IMTA demo, you'll find how much has been gone in to achieve this circularity. Yeah. So it's not only at a research level but also at different stages of implementation. Yeah. So to conclude, how we can make a robust balance between 3 E's. What were 3 E's? Ecosystem, environment and economy. Yeah. And this is exactly what happens. Environmentalists want one thing, economists want one thing. Yeah. What the best one is how to get a proper balance. So remember, transformation and translational approach. Yeah. How you can transform a side stream into value added product, and how you can translate A approach with B biomass. Yeah. That's very, very important. And this is called copying. But copying with a bit of sense, and to have innovation or innovative copying. Yeah. It's just not to copy it like, oh, dairy protein is very good, so fish protein is good. But fish protein is having its own issues, smell. So if you are able to get rid of fish smell, you are a millionaire. Yeah. That's only simple innovations required. Yeah. But that's complicated, because that is because of what? TMA, trimethylamine. Yeah. How can you get rid of trimethylamine to get rid of fish smell? You might come up, oh, we can encapsulate it, we can do this, right? Come up with an idea, and then you have a protein, fish protein, which can be used. Yeah. Some people who like fish-based product, those fish ingredient can be used into the soup mixes and all. Yeah. So that's the way to come up with the translation approach. Now, technologies are available, but we need innovative translation. Yeah. It's not that we say, oh, I work on high pressure, use the high pressure technology, you can make a product. No, that's not the approach. Yeah. Technology is there, but where to use it, when to use it, and how much to use it is very, very important. Other one is food system approach or value chain approach is the way forward. Yeah. You got any, suppose you go and buy a land or something, you'll see a lot of trees are there, another one, and you want to make a house of it. So you try to make use of each and everything, whatever is available on the land. But when it comes to these type of research challenges, we don't do that. Yeah. So even if your task of the PhD is produce food proteins or protein from oil seeds, or to use anaerobic digestion, or to make an energy, but you only focus on energy, you don't see other value chain. Yeah. If you see other one, or to see what other peoples are doing on a related business, so that you can make a system. Yeah. So then you can make a food systems approach and value chain, and that's the way you'll be able to solve lot of issues. So with these three things, what we discussed, what is food systems approach, resilience versus sustainability, some of the case studies, how best we can make zero waste approach, and 3 different ways we can balance economy, environment and ecology or ecosystem by using on-farm activities. That is not only to do with the pesticide or production, but also how you make use of straw and other things. Second one, deploying disruptive technology along agri-food chain, and third one is to achieve zero waste approach. So the main focus I was drifting more towards the wastewater side of it, because a lot of solid, there are plenty of examples are there. Yeah. So with this, thank you for listening.